Hey, welcome back, guys. So the last time what we did was we were just able to present our the game board, the sample game board that we have designed, and after that, there's one tool that I would like to introduce if you're not familiar with, which is a code formatting tool called Clang Format. So you can just use if you're unable to download it uh, via internet, you can simply do a sudo get install clang format. So you can do something like sudo apt get install clang format, and I already have it, so it's going to say that okay, it's already there, so you don't need to bother with it. But the way this is going to help us is we can use it like this. So clang format -i, so that will be in place. Pac-man cpp. Okay, well, pacman.cpp. Okay, what does it say? It did not. Okay, alright. Just got the spelling wrong. So clang format -i.cpp. That's all, and it's going to format our code, and it's going to make it more readable, and it's going to make it really neat. So moving on, what we want to do next is we want to go ahead with our handling these movements, handle up movement, down movement, left and right movements. So let's get started on writing the logic for handling the up movement of our Pac-Man game. So we are in the Pac-Man class, and what we expect here is we expect game board, and let's pass it by reference so that our memory is handled very efficiently. You don't have to duplicate your data structures when you pass it around functions if you have passed them by reference. Otherwise, if you're simply going to copy them, then that's not a very good practice, because these large data structures, it's not a good practice to move large data structures by sending them by copy. It should be either a reference or a pointer. That's much better memory footprint than simply copying them. Okay, enough with that. So let's get started on writing a code logic for handling of the up movement. So let's first make sure that our Pac-Man is at least alive and well. So we'll simply query pack life status, and if the assert hits, then it will mean that the Pac-Man is not alive and you're trying to have him move upwards. So Pac-Man not alive. Right. So when that is done, so let's just get the current position of our Pac-Man. You can use a more explicit declaration of pair, or you could simply use an auto current position. That would be just well, let's just say get position of our Pac-Man, so it will return the current position. Let's unpack it and say what is the current row. You don't have to actually get the current position, do you? You can simply say what is the current row using row variable, and unsigned row column, current column. That's right. And well, and you're trying to move upwards, so the way this logic is going to work is, let's say this is our board. Okay, again, let me attach my digital slate. Right, so let's say this is our board and this is where Pac-man is. Let's say this is where Pac-man is, P. And if it's at the 0th row and you're trying to have an upward movement, of course that won't be possible, right? So if it's 0, then you don't need to bother with trying to move Pac-man upwards. So that's what we'll do. So if we know that current row is 0, you simply return, because you don't have to perform any action in that case. Now, so in the other cases, let's say, let's get our eraser, let me erase it, and let's say this is where our Pac-man is. Let's say this is where our Pac-man is, and we want to move upwards now. We want to move upwards, so we need to query whatever is the entity sitting at this point and make decisions according to that. So let's say this is Pac-man's position would be R and C, so we need to look at what is R minus 1 C, and according to that we'll take our decisions. So let's get whatever is the entity at that position. So entity at, let's say, board dot get entity at, so at row minus, let's say current row minus 1, current row minus 1, and current column, let's see whatever there is. Okay, so according to, there could be multiple, no, there's going to be only one entity, of course, but then it could be of various type. Let's say if it could be of an empty type. The reason it could be of empty type is, let's say Pac-man has already visited and consumed, and if there was a pallet over there and it has consumed it already, then it's not, it won't make any difference. You just have to make changes to your row variable, that is move upwards, right? If there's a wall, then you can't of course run into a wall, so you'll simply bail out in that case. You won't worry about what's going to, so you just probably just stand over there, and rest is whatever happens next. And if there's a pallet, then you're going to consume it, and you're also going to update your score and all, and then you do all of those things. If there's a ghost, which means that Pac-man has chosen to run into a ghost, in that case, of course, the Pac-man will be killed. So let's write these logics one by one. So again, we'll visit our switch statement, old buddy. So let's, because we have queried whatever is there at the row minus 1, that is one step ahead in the forward in the upward direction. So we can simply use cell type, because after all it's only an enum, so it's going to return some integer value, right? So let's just say that if it's an empty type, if entity is empty, and it'll simply move up. Say cell type is empty type, all you'll have to do is make sure current row minus equals to 1, right? Perfect. So what you'll do is you'll make sure that okay, so now that you have moved upwards, so you'll have to place Pac-man at this position. So board dot update cell, with current row, current column, and cell type with Pac-man. Why isn't it showing? Yeah, moving on now. So now that we have updated position of Pac-man, so now we need to fill our board wherever we've come from, that is one position below. We need to fill it with whatever it is, an empty cell. So current row plus 1, because we have we did a subtraction over here, so we'll just add 1 to get to that position where we have come from. Current column would be the same, and cell type would be an empty type, right? So this is how we do it. So there are, I guess there are better ways to do it, but probably we'll do it in one of the refactoring videos. Later we'll try to do refactoring and reduce the number of lines of code and all those things. But I think this is a good enough start to have an explicitly writing everything so it is as clear as possible for someone who is a beginner. And yeah, let's move on. So after that we have updated our cell. What we'll do is update our Pac-man position. Let's say update Pac-man position. What we'll do is current row and current column. Probably in a later refactoring we wouldn't have to use this current row and current column. What we can do is simply use row and column and we'll try to render games. We'll try to render the board inside game state, so it does not have to track. So the movement logic does not have to be this complicated. But I guess this is good enough for a beginner video. So we can later refactor it in a later video. So if the cell type is a wall, then you don't have to actually do anything. You simply return. That's it. Oh, you can't. I mean, you could return or you could break. So let's just break. And anything would be fine, I guess. Or yeah, no, I guess let's leave it like that. It won't make much difference. It's going to return 1 or 2 statements later anyway. So if you are going to do an immediate return, so the difference is it'll be a slightly optimized way of doing it, because yeah, you don't have to deal with that compiler can do a lot of optimizations if you have an immediate return versus a break. So that makes it much more difficult. Anyways, that's let's not concern ourselves with that for now. So if it's a palette, what we'll do is, so we'll update Pac-man score. Let's update its score and let's move up and do the update this logic again. Probably this could we could probably make this is a repeated work, right? Yeah, I guess let it be for now. We'll take care of it later. And then the same thing, update position followed by a break. Okay, so we forgot break over here. So how about if we, so since this is, let's just break here and let's break here. Let's do one more thing. Let's add one more function where we can reduce all this redundant work. Move up util. So this is going to take all of this work away. Let's put it over here, and let's say it's going to need a game board object and everything else, and current row and current call. That should be, that's okay, I guess. Right. So it's also going to need current row and current call. Current row and current call. That's right. So yeah, I guess this is okay. So it's going to simply update the Pac-man position and fill the prior position with an empty cell, and finally do an update in its object variable. So we'll just perform a move up util function over here. So move up util, it's going to take a board variable, and it's also going to take current row. Do we really need current call? We don't. So I guess we don't need to. Okay, this was anyway. Just going to throw an error. Let's say current call is going to be same as the column in which Pac-man is. So no surprises there. Right. Move up util. So right, we can even move this one. So we can even move this one over there. Right. So it's going to do this move up util and break. Right. And in this case it's simply going to break. Do we have to even include it? So I guess we don't. In that case we might as well remove it, right? So here this is all being taken care of, so why don't we just do move up util and current row. Right, and right. So I guess this is it. So we're done with empty and palette. If it's a wall, we don't really care what happens, you just stand right there. And if it's a power palette, let's just case where our cell type is power palette. We'll increase the score by 50. We can configure even these magic numbers like 50 and 1, but let's keep them static for now, and simply do the moving up ritual. So that will be the same, and we'll break. So power palette is done. Now these were all more or less the same, but there's differences with the when you encounter a coast. So let's say if you have run into coast while you're moving up, then this is what you have to do. So now we'll just try to kill Pac-man. First of all, let's get Pac-man killed. And the way it works is it's going to send us a signal, because recall that we have implemented kill Pac-man function which will return us a signal, right? So it's going to either return us game over when you have run out of lives, and when you have and when you still have life left to play a game further, then you can simply return a signal of start next life. So we'll just make our decision according to that. Let's say signal would be kill Pac-man. Kill Pac-man would send us a signal, and let's just compare what is going to be. Let's say if this signal is going to be signal game over, if it's going to say it's a game over, then what you have to do is you have to make sure that in that case lives are indeed 0, and give us a prompt saying that kill game over signal while Pac is alive, right? Okay, just that assert. It just helps us with the debugging process becomes much easier in this case. So let's finally set is alive to false, and we'll finally return from here because the game is over at this point. Right, and if that is not the case, you'll set is alive to be true, and you'll start over alive again, and you'll break. Right, so we're going to handle lives. We're going to handle. Okay, so because we've already dealt lives equals to lives minus 1 in the kill Pac-man function already. So if you can see that we've reduced lives to reduced it by 1, so we won't have to do it here again, and this also makes it much more concise. Anyways, that and is because the setting is alive equals to true is because here it should be set to false, which it is rightly set to false. With that said, most of our handle up movement logic is done here, and so let's just give a default case. Let's just assert here saying that unexpected up movement request, because this point default case should never be hit because it should either be a ghost or it's going to be a power palette. Okay, so I see what is going on here. So if you don't have one of these, then it's going to, let's say, what if it has a wall? In that case, it's not going to find wall over here, and it might simply come at the default case. So let's just have wall for the sanity check. Empty and wall, and we could simply return or break from it. So that is our up movement logic. So we're done with up movement. Now let's write code for down movement. So it will be more or less the same. We'll have an utility function that will do all the redundant work. Instead of doing the redundant work in each switch case, we'll just have one function doing that for us. So this will take a game board. Game board, right? So let's have the assert first. So this assert helps us in recognizing if we are trying to move Pac-Man while it is not alive. So let's have our current position, current column and current row variables. So you're trying to move down. So when you're trying to move down, so you have to make sure that you're not on the very last tile or very last coordinate on our board. So the way we make sure about it is, let's say if current call is same as let's say get board dot get get rows, because you don't want to run below a certain row, so that won't be a valid so if it's the very last row, that will be number of rows -1, then you don't have to bother trying to move down. In that case you can simply return. Otherwise you will simply get the entity at that position. So let's say board dot get entity at it will be current row, and so it will be current row +1, because you're trying to move down, so it has to be one row below where you're standing, and the column stays the same, right? And again with our switch statements, switch entity, right? This column is not supposed to be here. So let's see if our first case where the cell that we're trying to move to is empty. Let me just, if the cell that we're trying to move to is empty, in that case all we will do is increase. Okay, so let's have that function which does our repetitive work. So that should be move down util, so which will take game board, and it will also take, what does it take, current row, right? Unsigned current row. So what's the repetitive work? So we'll increment the current row by 1, and we'll make sure the board is updated, so that will be current row. Call will be the same as whatever is the Pac-man column, current column, and the cell type would be Pac-man, because that's where you're moving to. Once that is done, we'll also fill the void that Pac-man already left with an empty cell, just to be sure. So that will be current row -1, because that's where we are coming from. Since we've incremented it, we need to decrement it to come to the original position. Column remains the same, and cell type will now become an empty cell. Alright, so after that is done, we'll simply update position with our current row. Call remains the same. Great. So this is mostly done. So what we'll do is, if it's an empty cell, what you'll do is move down util. That's all you'll do. Board, pass board, and current row. That's it. And you'll break. Now if it's let's say if it's a wall, all you do is return. You'll return or you break. Let's simply case let's say if it's a pallet. So what are you going to do when it's a pallet? So as usual routine, so you'll increment your score by 1, and you will perform the move down util. So sorry, not move up util, move down util. That's what you're supposed to do. Game board and current row would be the same. And you'll simply break at this point. Okay, great. And if it's the case for par palette, or we'll do the same thing, but it has to be, the score has to be incremented by 50 instead of 1, and perform the usual ritual of moving down with board and your current row, and you break. What if it's ghost? Again, it'll be very similar to the way we did it in handling of the up movement. Okay, cell type, ghost is right there. So first of all, let's kill it and get a signal. Kill Pac-man, get a signal, and well, it's the same logic as we implemented here. It is the exact same logic that we're trying to implement over here. That if you have signal, if it signals as game over, then you simply set this is alive to false and return. And in any other case, when there are still lives left, you'll again set as alive to true and break. That's it. And in the default condition, we'll simply try to have an assert, because our code should not be reaching that position. So I guess this sums up our handling down movement, and this is the switch boundaries and handle down movement. Now what we want to do is at least try to test this code. Let's first let's perform a clang format. So okay, so as you can see, it just nicely does the code formatting. Now let's try to build our game. That should be, let's say, O3 M-O Pac-man. Shouldn't give any errors, so it gives a bunch of errors. Let's try to resolve them. Unexpected. Okay, there's somewhere it's missing. Okay, we have missed a semicolon over here, right? And okay, again a bunch of errors. Pac-man is not a member of cell type. Is Pac-man not a member of cell type? Let's check that out. Okay, we've used it enough time, so let's just go ahead. Okay, it's supposed to be Pac-man T and not Pac-man. It's supposed to be Pac-man T. Right, and that is move up util, and let's just check if we've done the same thing with move down. Let's try to build again. Again a bunch of errors. Assert was not declared in the scope. Okay, so this is supposed to be assert, right? What is this? The same mistake. Assert action move cannot convert. So what is this? So we're trying to game board pointer to game board. Okay, so this returns a pointer. Let's just dereference it and make it as an object, right? So I reckon this should be the same for, no, I guess that should be fine. Let's try to build again. Fewer errors, that's good. Handle left movement, do you mean handle up movement? Okay, so these are not yet implemented, so it's obvious that it's going to error out. Now it shouldn't have any errors left, and it doesn't. So in member function, const warning reaches end of the void function. So you're not returning anything here. That's fine, I guess. We'll use the compiler option to ignore all the errors. So in that case, we may as well try to run again. So we're not able to perform any up or down movements yet. Okay, that's fine. So let's just hope that in a future video we'll be able to get our Pac-man moving. So once we'll have all of these movement functions implemented, then we'll probably be able to move our Pac-man around regardless of whether ghosts are moving or not. Of course they're not going to move because we haven't implemented ghosts movement yet, but in future videos we are going to implement the ghost movements. Thank you guys.